Good morning. Excuse me. So today we're going to be looking at the relationship between perimeter and area. And I have to tell you, this is a fairly, excuse me, oh my goodness, this is a bit of a tricky concept, but it's actually sort of cool the way it works. So let's do a quick review of what perimeter and area is. So perimeter is the outside border of a shape, and area is the amount of space inside the shape. So in this particular case, the red outline is the perimeter, the green space inside is the area. So what I want to look at two questions today. And the first question is this: if two shapes have the same area, do they always have the same perimeter? And if I change the area of a shape, do I have to change the perimeter? So I want you to think about those two questions for a second, because it might seem pretty obvious that if you change the area, you're changing the perimeter. But can you change the area without changing the same perimeter? So without changing the perimeter, sorry. So let's take a look at a little rectangle here. We're going to take a look at this rectangle. And if I look at this rectangle, I can see that it's 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. So measuring the perimeter, I'm going to count the squares that go around, and it's going to be 3 by 3 and 7 by 7. And if we take a look then at how to do the perimeter, 3 plus 3 plus 7 plus 7, the perimeter of this particular rectangle is 20 centimeters. The area, remember I mentioned before, you're just going to multiply the 3 by the 7, the width times the length. 3 times 7 is 21, and remember it's centimeters with the little 2 squared, centimeters squared, square centimeters. So for this particular rectangle, that's the perimeter, and that's the area. And funnily enough, they're almost the same, except they're different units, but they're almost the same. So let's take a look to see what happens if I stretch it out. All right, so what I've done with this rectangle is I've got the same perimeter. I've taken 2 from the 3 and stuck it on the 7, and taken 2 from this 3 and stuck it on the 7. So this becomes 7 plus 2, or 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this becomes a 1, 1. All right, so it's still, believe it or not, the same perimeter. I've squished this, taken this line and moved it onto here, taken this line and moved it onto here, taken this line and moved it onto here, and this line and moved it onto here. And I have a new rectangle that's skinny, that's 9 by 1. All right, it's the same perimeter. 9 plus 1 is 10, 9 plus 1 is 10, 10 plus 10 is 20. But let's take a look at what it does to the area of this rectangle. And you can sort of just look at it and go, I think if I had this much pizza and then I had this much pizza, I probably want this much pizza. It looks bigger, doesn't it? So let's take a look at the actual calculations. So the perimeter, like I said before, is 20. The area is only 9. So it's gone way down. 1 times 9, 9 centimeters squared. So it's gone way down. So you can see that I've kept the perimeter the same, but in fact, my area has dropped a lot. All right, so certainly then my perimeter can stay the same, but I can change the area just by changing the dimensions, the length and width of my rectangle. So we're going to look at a problem here, and I'll tell you right off, this problem is really a grade 6 sort of problem. This is not an easy problem, so if you get this, you are rocking it, because it's 2 grades ahead of where you are right now. So, but I think you can get it, because I know you guys have got this concept down, I think, just by looking at your work. So I'm pretty sure that you will be able to do this. So let's take a look at this. If a rectangle has a perimeter of 24 centimeters, what is the largest possible area it can have? All right, so perimeter of 24 centimeters, what is the largest possible area it can have? So I have to think, first of all, because I haven't been given a lot of information here. I know it's a rectangle, and I know a rectangle has opposite sides that are of equal length. And I know that all the way around the rectangle is 24. I don't know what the area is because I'm going to change this I'm going to change the perimeter dimensions to see if I can manipulate the area. So the first thing I'm going to do if I was tackling this problem is I go, well, I need to know, in order to calculate the area, I need to know the length and width of my imaginary rectangle. And I'm just going to invent them. I'm going to pull them out of the air. So 24 has to be divided into four numbers: the width, the width. But the two lengths have to be the same, and the two widths have to be the same. So two of the numbers have to be the same, and the other two numbers have to be the same. So I'm going to go, well, the easiest way to start a problem like that is to go low. So I'm going to say the side lengths for the small side is only 1 centimeter. All right, so if I go 1 centimeter, so let me just draw this quickly. So if I go 1 centimeter here, so that's just one, and then just stretch this out, this would have to be 11 then. What are we at? 5, 6, 7, 8, 9, 10, 11. So if you look at this, I've got a 1, that adds up to 2, which means I'm going to have 22 left. So I need to have 11 on both sides because 22 divided in half is 11. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. So what is the area of this particular rectangle? Well, I can just count it. It's 11 squares. So I know that the area in this particular case equals 11, which is pretty low. So I'm going to change up my dimensions a little bit. So I'm going to alter it now. Instead of going 1 centimeter, I'm going to bump it up to 2. So let's see what that looks like. I'm just going to copy this little box here so that I can bring it to the other page. See what it looks like. Whoops. So here's my first example. And in my first example, my area equals 11. So now I'm going to change it, and you can see the pattern here. I've just bumped one off of these ones and added it to these ones. So the actual perimeter is staying the same each time. It's maintaining 24. I've just changed how many is in here and how many is in here. So I'm adding one to this, taking away one from these two. So here I've gone 10 by 2. So let's draw my 10 by 2 rectangle. So it's going to have a short length of 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes right to the end of the page. So now my 10 by 2 rectangle, I can calculate the area now. So it's going to be 10 on the top by 2 on the side. And remember, area is length times width, 10 times 2. So the area of this rectangle is 20. So you can see it's already made a huge jump from this one over here. Definitely going up quick. All right. Now, the next example I've got here is I've added one more to the short side, taken away one from the long side. All right. My new rectangle is 3 by 9. So I'm going to go down 3 this time and I'll go across 9. 1, 2, 4, 5, 6, 7, 8, 9. So you can see they're getting one shorter each time. I'm going to drag this one over just so that they're lined up properly. So they're getting one. Oh, that's not going to work because it's off the page. There we go. So it's getting taller this way, but shorter this way. So this one is going to be 9 by 3. And now I can go 9 times 3. The area of this one, 9 times 3, is 27. So you can sort of see the pattern here. It seems that as this number gets bigger and this number gets smaller, my numbers are going up. All right, as this number is getting bigger and this number is getting smaller, my area is going up. So what I'm going to do now is I'm going to go, well, if that's the case, then I can sort of make a guess as to maybe where I should go with this. Can you think of where you would go so that the perimeter is still 24, but the area is big? So let's take another shot at this on a blank page here. So I still need my 24, but I want to go big on for the smaller side and shrink the larger side. So I went 3 and what did I do? 3 and 9. So 9 and 3. So if I go up again, it's going to be 8 and 4. And then if I go up again, it'll be 7 and 5. Let's try 7 plus 7 plus 5 plus 5. All right, let's try 7 plus 7 plus 5 plus 5. So if I take a look at that rectangle, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So now I have, and it's still got a 24 perimeter. 7 plus 7 is 14. 14 plus 10 is 24. So it's the same as this one, believe it or not. Still the same around. But now I've got a pretty huge space that I'm taking up here. Anybody know what 7 times 5 is off the top of their head? 7 by 5 is in fact 35. So that is way bigger than 11 here, right? Way bigger. So have we gotten to the best, largest possible area? Well, let me see. By definition, a rectangle is a closed shape with 490-degree angles and opposite sides are parallel. All right, so, or equal length and parallel. So, is a square a rectangle? It actually is. By definition, it is. So we can actually go to a square shaped rectangle. All right, so let's take a look at what that's going to look like. Wait a minute. Which would mean our 24 would be 6 plus 6 plus 6, 6. Perfect 6 by 6 square. So let's take a look at a 6 by 6 square. Is that it? Yes, there's my 6 by 6 square. And then we're just going to multiply 6 by 6, and our area would then be 36. All right, so here we have the biggest possible area for a rectangle with a perimeter of 24. All right, so that, believe it or not, has got the same perimeter as this. The same line around, same distance. It's just been pulled out to its maximum amount and it's made it really huge when it comes to area. So there's an interesting relationship then between area and perimeter. What you will find is the largest area happens when the dimensions of the shape are as close together as possible. And the smallest area happens when the dimensions of the shape, the length and the width, are as far away from each other as possible, still adding up to the same perimeter. So that's the lesson for today. I have a couple of questions in the homework that relate to this. And yeah, enjoy the rest of your day.